Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland. And this short video, another video in our series of videos dealing with coordinate geometry of the line, is going to present, I suppose, let's say a proof, or let's say a derivation, for the formula that allows us to calculate the area of a triangle when one of the points of the triangle is the origin. In particular, the formula that we're looking for, and the formula that we're interested in this particular case, is, well, it's something like this. The formula, what we need to derive is that that's half, given two coordinates, where it's given three coordinates, where one of them is the origin. It's a half of x1 y2 minus x2 y1. Okay, it's the absolute value of this here. Yeah, that this gives us the area of a triangle, where one of the points is the origin and the other 2 points are x1 y1 and x2 y2. So we'd like to derive this particular formula for the area of a triangle. Okay, so well, let's just create a triangle that has one of its vertices as the origin. So what I'm going to do is I'm just going to create an x-axis, okay, and a vertical y-axis here. Okay, so here's our y-axis, and I'm going to create a triangle, and one of the vertices is the origin, so one of our vertices is going to be here, and let's say we have another vertex here, and let's say we have another vertex here. Let's call it the origin, and we have A and we have B. Okay, and that the coordinates of A are, let's say, x1 y1, and that the coordinates of B are, let's say, x2 y2. Okay, so we have a triangle. So maybe if I just grab my ruler, where's my ruler here? So the triangle looks something like this. Okay, so the triangle is here, and let's say here we go here. Okay, to the origin again. Okay, this triangle, and it's this triangle here that we'd like to calculate the area of. The important thing here is that this is not necessarily a right angle triangle. Okay. So we'd like to calculate the area of this. So how the hell are we going to do it? So we need to do this in parts, okay? And let's just recall that the area of a right angle triangle, okay, of a right angle triangle, okay, okay, let's say is half the base. It's half the base times the perpendicular height times the height. Okay, let's just keep that in mind. This is important for us. So what we're going to do is we're going to create a number of right angle triangles from this particular with respect to this particular coordinate system. So the first thing that I'm going to do is I'm just going to drop a perpendicular, okay, from the point A down to the x-axis, and this is going to be parallel to the y-axis. Okay, so I'm going to drop a perpendicular down, okay, and what that allows us to do is allows us to create a new triangle. Okay, the triangle that I'm interested in here is this triangle. I'll color it in. It's the triangle that's colored in red here. Okay, let's just keep an eye on this triangle. Okay, now we can calculate the area of this triangle because this is a right angle triangle because we dropped a perpendicular, okay, to the x-axis here. So this is a right angle triangle. Okay, this coordinate here is, well, we dropped the perpendicular from A that has x coordinate for x coordinate x1. So this coordinate here is, I suppose, it's x1 0. Okay, so this is at the position x1. In which case, this length here of this triangle, the length of it is, well, it's from 0, the origin, to x1, so the length is x1. And the height of the triangle is, well, it's y1 from this point x1 up to, which is x1 0, up to A, is of height y1. So actually, the height of this triangle here is that height there, which is y1. So the area of this triangle OAB, well, let's call this actually OAB. Let's call this point here point C. Okay, so OAB, and this is the point. Let's say the point C here. The area of the triangle, okay, OAC, is simply equal to, it's a right angle triangle, so it's half the base times the height. So it's a half x1 times the height, which is y1. Okay, so there you go. There's a we know the area of that particular triangle. Let's do something else now. Okay, what I'm going to do now is I'm going to produce a line parallel to the x-axis through the point B. Okay, so that I create a shape that looks something like this. Okay, and then I'm going to drop a perpendicular parallel to the y-axis. I'm going to drop it down here. Okay, so once again, parallel to the y-axis, I'm going to drop a perpendicular. Okay, which is to here. So let's say that this parallel to the x-axis meets at, let's say, ABC D, okay, and when we drop the perpendicular parallel to the y-axis, that meets at E. And what we end up with is a square. Isn't that right? Yeah, this is, well, not necessarily a square. Okay,